Hi, I'm Raymond Lin, and this is Strategic Math. In the third and fourth lecture, we're going to talk about geometry. We're not going to talk about geometry involving trigonometry or complex equations. We're just going to talk about plain old geometry, how to use new lines and new shapes to solve our problems. In this third lecture, I'd like to talk about triangles out of nowhere. I'll help you build the initiatives for these new lines and these new shapes. Let's get started with today's lecture. Our today's lecture will surround this theme, and there will be 7 questions with this theme. This theme is that there's a triangle in a square, and this triangle has an angle of 45 degrees. Remind you that angles will not be accurate in this video for the purpose of animations. First, let's look at our question 1. It asks that if MAN equals to 45 degrees and AD equals to 1, then what is the perimeter of the triangle MNC? You can pause the video here to solve for the problem. Well, to answer this question, we'll have to think about something. Because MAN equals to 45 degrees, this means that the angle DAN plus the angle MAB will also be equal to 45 degrees. From these two, we can get a hint. We'll try to combine these two angles, and this is the key for this problem. We'll replicate the triangle ABN and rotate it by 90 degrees. In this way, we can form the triangle AM'D. Notice that in these two triangles, they both have the degrees of 45 degrees, and they both have the sides AN. AM is also equal to AM prime. This means that the triangles AMN and ANM prime are congruent with each other by the property SAS. From this, we can solve our problem. The perimeter of MCN will be equal to MC plus CN plus MN. We can expand it into this form, where MN equals to ND plus DN prime. We can combine ND and CN to form CD, while we can change DN prime into BN. We can then combine MC and BN to form BC. This means that the perimeter will be equal to BC plus CD, which is our answer 2. We now solved the problem, but now let's look at something that is quite interesting. If we draw the perpendicular line from the point A to the line MN, we can find something very interesting. If we draw ADN prime again, we can find that because these two are congruent, this means that AH will be equal to AD. From this, we can get that AHN is congruent with ADN. From this, we can get that HN equals to ND. Similarly, we can get that BN equals to MH. From this, we can now again solve our problem using this new way. We can find that MC plus CN plus MN equals to MC plus CN plus ND plus BN. We can then combine them and get that the answer equals to 2. So in this second way, we can notice something. This is that AM is the symmetry axis for the triangles ABN and AHN, while AN is also the symmetry axis for the triangles ADN and ANH. From this, we can get a property. The angle DAN will be equal to NAH, and the angle BAM will be equal to MAH. So these are the two ways that we solve problem 1. Now let's look at question 2. It has the same conditions, but now it asks for the minimum of the area of the triangle AMN. So to solve this question, you'll have to know something about how we can solve for the maximum and the minimum of a number by using the discriminant of a quadratic equation. So if we let MC equals to X, Cn equals to Y, and Mn equals to Z, we can get two equations. First is that by the Pythagorean theorem, we can get that Z squared will be equals to Y squared plus X squared. From question 1, we can get that X plus Y plus Z equals to 2. We can further simplify X into 2 minus Y minus Z. We can combine these two equations and get this. By further expanding it, we can find that it is a quadratic equation of y. Because y is a real number, we can find that the discriminant of y must be greater or equal to 0. This gets us to this. We can further simplify it to this form. From this, we can get the equation like this. Notice that because z is a length, this means that z must be greater than 0. So z must be greater or equal to 2 times the square root of 2 minus 2. This means that the minimum of z will be 2 times the square root of 2 minus 2. Now let's look at how we will solve for the area of AMN. If we do the same thing, we can find that these two are congruent with each other, which means that the area of these two will be the same. So the area of the triangle AMN will be equal to 1 over 2 times n prime, which in this case is z, n times 1, which is AD. So we can get the minimum area for the triangle AMN is square root of 2 minus 1. And this is how we answer our question 2. Now let's look at question 3. It asks that if we draw the perpendicular line from the point N to AN and draw the perpendicular line from the point N to AN, then prove that the angle MAN equals to 45 degrees will be covalent with the condition BFD are collinear. So we'll first try to prove this from right to left, where we know that BFD are collinear. First notice that because the angle AFM equals to ABC equals to 90 degrees, this means that AB and F are concyclic. From this, we can get that the angle FNA will be equal to FBA, which in this case will be equal to 45 degrees. We can further derive that the angle MAN equals to 90 degrees minus the angle FMA, which is just 45 degrees, and this is how we prove it from right to left. We'll now try to prove this property from left to right. First, we know that the angle MAN equals to 45 degrees. We'll now draw the perpendicular line from the point A to the segment MN. We'll also connect the lines EF, FH, and FD. First, notice that we already talked about this symmetry. Where AN is the symmetry axis, we can find that AHN is symmetrical to ADN. This also means that the triangles FHN and FDN are congruent with each other. From this, we can get that the angles NFD equals to HFN, and this completes the first part of our proof, and this is important in our later part. We can then see that there are two sets of concyclic. One is that OH and F are concyclic, and the other is that EF and N are also concyclic. From these two sets, we can get that the angle OFH equals to ONH, which is also ENM, which is equals to EFM. From this equation, we can now continue our first part. We find that the angle NFD equals to 90 minus the angle OFH. This is just equal to 90 minus EFN, which is just the angle AFE. And this is what we get. NFD equals to FFE. This also means that EFD are collinear. Similarly, we can use this way to prove that BEF are collinear. And this is how we get that BEFD are collinear. And we've completed our question 3. So now let's look at question 4. If we know that the angle MAN equals to 45 degrees, prove that AFE will be equal to ANB. Well, we already know that there's a symmetry concerning the axis AM. From this we get that the angle ANB equals to the angle AMN. We also know that EFMN are concyclic. This means that the angle AMN will be equal to AFE. And this is how we prove our question 4. So now let's make a quick summary. First, the perimeter of the triangle MNC will be equal to 2 times AD. Second, we know that the triangles AMN will be congruent with the triangle AN'. Third, we can get the symmetry, where AHN is congruent with ADN and AHN is congruent with ABN. Fourth, from question 3, we can get that if the angle MAN is 45 degrees, then BEFD are collinear. And fifth, we can get that the angle AFE equals to the angle ANB. Let's now look at question 5. It says that the angle EAF equals to 45 degrees and AG is perpendicular to EF. EG equals to 2 and GF equals to 3. What is the length of AG? Well, from the things that we have talked about, you'll get the initiative that we can put such a triangle into a square. We'll now put on 2 and 3. Because we know that such a symmetry exists, we can know that B will equals to 2 and DF equals to 3. Then we'll let AD equals to X. This means that EC equals to x minus 2, FC equals to x minus 3. By the Pythagorean theorem, we can get this. By further simplifying it, we can get that x either equals to 6 or negative 1. But this length must be a positive number, so negative 1 will not be the answer. From the symmetry, we can further derive that AG equals to AD. This means that our answer for AG is just 6. So because we know that such kind of question exists, it will be very easy if we just put the triangle into a square. But if you don't know this initiative, it might be a little bit harder. Let's now look at question 6. If EAF equals to 45 degrees, let B equals to X, FD equals to Y, and EF equals to Z. Then prove that X squared plus Y squared equals to Z squared. So first you can observe that this equation looks like something from a right angle triangle, where we can use the Pythagorean theorem to prove this. So let's try to make this kind of triangle. We can first see that, as usual, FAD and EAB will add up to 45 degrees. So we'll try to combine them. Then we'll connect EF prime. Let's put on x, y, and z. From this symmetry, you can know that EF prime is just z, and BF prime is just y. Notice that ADB and ABE are both 45 degrees. This means that when these two combine together, it will add up to 90 degrees. And this is just how we prove that x squared plus y squared equals to z squared. We'll now look at our next question, question 7. It asks that if EAF equals to 45 degrees, BE equals to 3, EF equals to F, then what is the area of the triangle AFD? Well, to solve this question, it is actually quite easy. It is just the same diagram we've been seeing all through this lecture. We already know that x squared plus y squared equals to z squared. This means that we can solve for FD, and in this case, FD equals to 4. So we'll now solve for the area of the triangle AFD. We can find that the height of this triangle will just be BD over 2 because the triangle ABD is an equilateral triangle. This means that the answer for this question is 12. And that is how we solve this problem. Well then, but we have another thing that we need to talk about. Remember that AE, we said that it is a symmetry axis. This means that we can draw this symmetry again. AF is also a symmetry axis. We can find that using this way of drawing, we can also prove that x squared plus y squared equals to z squared. So we've concluded that we can use the two initiatives that we already talked about in question 1 to prove the theorem in question 6. I'd like you to remember these two initiatives because these two will be really important in our next lecture. Let's now do a quick summary. The 5 points listed above is the points that we've already talked about. The 6th point is that BE squared plus FD squared will be equal to EF squared. And the 7th point is that we have found that the angle EHF will equal to 90 degrees, and ABE and AHE, AHF and ADF are congruent with each other. Thank you for watching the whole lecture. I'll advise you to go through the video again and review those initiatives that I talked about. I'll see you at the next lecture, where you'll see many interesting problems that you'll solve with today's initiatives. See you then.